Welcome to Data Engineers Academy. In this video, I'll walk you through building a fully automated pipeline that watches a GCS bucket and loads any new file straight into a BigQuery table using n8n. First, we head into Google Cloud Console and open APIs and services. Before n8n can talk to our bucket or our BigQuery table, we need APIs turned on. Click on Library. We need Cloud Storage API in enabled state. Just search for Cloud Storage API in the API library and hit Enable. For me, it is already enabled. Next, we set up the OAuth consent screen. This is what governs who's allowed to sign in and use our credentials. Now open Branding and add our own Google account under User Support Mail. Since we're the only ones using this, we keep the app in testing mode and add our own Google account under Test Users. That skips Google's full verification process entirely, since it's not a public-facing app. And also we add our account under Developer Contact Information. And now open Audience and check whether the user type is internal or external. If it is external, make it internal. And add our own Google account under Test Users for testing mode. With that in place, we switch over to our local machine and start the n8n server from the command line using n8n start. Once it's up, it tells us it's ready and listening on port 5678. That's where we'll be building our workflow. Back in Google Cloud, we create our OAuth client, a web application type, and this is the piece that actually issues the client ID and client secret n8n needs. Once it's created, we copy both values immediately, since the secret is only shown once. Now we jump into n8n itself and start adding credentials. We search for Google Cloud Storage OAuth to API first. This is where we'll paste in that client ID and secret, and where we grab the redirect URL that has to be registered back in Google Cloud. Now go back to Google Cloud Console and open our OAuth client. Under Authorized Redirect URIs, paste the redirect URL, which we copied from n8n, and click Create. After that, a pop-up with client ID and client secret will appear on the screen. Now copy these two and save them on Notepad. We will use them later. Here the client is created, as we can see. Now return to n8n and open the Google Cloud Storage OAuth to credential. Copy the client ID and client secret that we saved earlier in Notepad and paste them into the respective fields. Then click Sign in with Google. Select your Google account and allow n8n to access your Google Cloud Storage. After successful authorization, the credential will show as connected. Now n8n is ready to access our GCS bucket. In n8n, create another credential and select Google BigQuery OAuth to API. Then return to n8n and enter the same client ID and client secret. After entering the details, click Sign in with Google. Select your Google account and allow n8n to access your Google Cloud Storage. After successful authorization, the credential will show as connected. Allow access to BigQuery. Once completed, the BigQuery credential will also be connected. So now we have two credentials, one for Google Cloud Storage and one for BigQuery. Next, we need to make sure our Google account has the required IAM permissions. Go to IAM and Admin and then open IAM. The account we connected to n8n should have permission to work with Cloud Storage and BigQuery. For Cloud Storage, we can use Storage Object Admin. For BigQuery, we need permissions such as BigQuery Data Editor and BigQuery Job User. These permissions allow n8n to read and manage files and load data into BigQuery. Now let's create the actual workflow. Our workflow will contain several nodes. The flow will start with a schedule trigger. The first node is the schedule trigger. Search for it in search bar. Here change days to minute and schedule it for 1 minute. We will configure it to run every 1 minute. This means n8n will automatically check our bucket once every minute. There is no need to manually start the workflow. Next, we need to add a Google Cloud Storage node. Search for it in search bar. After that, choose the operation to get a list of objects. Select our bucket and enable return all. This node will return the files currently available in the bucket. Next, we need to add a filter node. Search for filter in the search bar and add it to the workflow. In the filter condition, select the file name using $json.name. If this code contain any spaces, remove them and enter it. Set the condition to does not contain and enter .json. This will skip all JSON files and allow only the required files, such as CSV files, to continue to the next step. Here I forgot to add .json, so I came back and added .json at value 2, and now I saved it. Next, we need to add another Google Cloud Storage node. Search for Google Cloud Storage in the search bar and add it to the workflow. From the operation list, select Get Object Data. In the bucket name field, select the same GCS bucket that we used in the previous step. For the object name, use the file name from the previous node. Enter this expression, $json.name. Make sure there are no extra spaces inside the expression. If you copy and paste it, check the expression carefully and remove any unwanted spaces. This node will download the actual file from the GCS bucket. After this step, the downloaded file will be available as binary data in n8n. Next, we need to add an extract from file node. Search for extract from file in the search bar and add it to the workflow. From the operation options, select extract from CSV. Make sure the input binary field is set to data, because the downloaded file from the previous step is stored as binary data in this field. Next, we need to add a Google BigQuery node. Search for Google BigQuery in the search bar and add it to the workflow. From the operation options, select Insert Rows. In the credential field, select the BigQuery credential that we created earlier. Next, select your project, dataset, and the BigQuery table where you want to load the CSV data. And save it. Next, we need to add another Google Cloud Storage node. Search for Google Cloud Storage in the search bar and add it to the workflow. From the operation list, select Create an Object. In the bucket name field, select the same GCS bucket that we used earlier. For the object name, we need to specify the destination path inside the bucket. Enter this expression, processed plus $binary.data.fileName. Make sure there are no extra spaces inside the expression. Next, enable the binary data option and make sure the binary field is set to data. This node will create a copy of the downloaded file inside the processed folder. Next, we need to add another Google Cloud Storage node. Search for Google Cloud Storage in the search bar and add it to the workflow. From the operation list, select Delete an Object. In the bucket name field, select the same GCS bucket that we used in the previous steps. For the object name, use the original file name from the previous node. Enter this expression, $json.name. Make sure there are no extra spaces inside the expression. If you copy and paste it, check the expression carefully and remove any unwanted spaces. This node will delete the original file from the main folder of the GCS bucket. Now that all the nodes are connected, let's test the complete workflow. Click Execute Workflow at the bottom of the canvas. This will run all the nodes in sequence. Watch the nodes as they execute. Let's put the automation to the real test. Here the bucket name form before is not same. But I have done the same process with bucket name, so I changed bucket. Here's our bucket, Sun4256, and right now the only thing inside it is the processed folder from our earlier runs, meaning the root is clean, with no files waiting to be picked up. I'm uploading a new file here, diri.txt, straight into the bucket root. Once it finishes, there it is, sitting right alongside the processed folder. This is a brand new file the workflow hasn't seen yet. Here after workflow executed. Go back to Google Cloud and refresh the page, then we can see this. Just to confirm what's already been handled, let's peek inside the processed folder. And here's every file we've loaded so far in earlier tests. Data, dep, dep1, details, and now diri as well, each one already sitting here from a previous run. Now let's jump over to BigQuery and check our mp_details table. Query the table and enter star and execute the query, just to see where things stand before we run our next test. And here's the data currently sitting in the table, 12 rows in so far. To really push this further, I'm going to prepare a fresh test file locally. Here's ram.txt, currently holding 4 rows, 101 through 104. Let's update this with a new batch of records instead, so we can clearly see brand new data appear after this run. I'm replacing the old rows with a new set, 111 through 114, named Shiny, Devanshi, Bhanu, and Anjali. This gives us a distinct, easy-to-spot batch, so when we check BigQuery afterward, we'll know for certain this exact data came from this exact file. With the file saved, let's go back to the Google Cloud Storage console and upload it. I'll browse to the desktop, select ram.txt, and upload it straight into the bucket root, same as any real file landing there. And there it is, ram.txt now sitting in the bucket root, uploaded just now. From this point forward, I'm not touching n8n at all. This is the real test. Does the schedule pick this up entirely on its own? Let's wait for the schedule to run, then come back and refresh. Checking the bucket root again. ram.txt is still sitting here for a moment, so we give it a little more time for the next scheduled run to kick in. And now, checking again, ram.txt is no longer in the root. It's been picked up. Let's open the processed folder to confirm it landed there instead. Finally, the real proof, back in BigQuery, running the same query against mp_details. And here it is, 16 rows now, with our 4 new records, 111 through 114, sitting right at the bottom. The workflow found the file, loaded its data, and archived it completely on its own, with zero manual intervention. That's the automation working exactly as intended. Drop a file in the bucket, and within a minute it's loaded into BigQuery and safely archived, with no one needing to click a single button in n8n. Thanks for watching. See you in the next video.